Let us discuss the next problem, which is taken from the chapter Ray Optics. A convex lens of focal length 20 centimeter, that is a biconvex lens, is placed 5 centimeter in front of the convex mirror having a focal length 15 centimeter. So this convex mirror focal length is 15 centimeter. An object of length 2 centimeter is placed at a distance 10 centimeter from the lens. You can see that the object and lens are placed at a distance of 10 centimeter. Find the location of the three images. And here the question is only to determine the location of the three images. The length of 2 centimeter is not going to play any role here, because if they ask a magnification related problem, then this length 2 centimeter will be very useful. And here, since we are going to find only the location of the three images, so let us neglect the length of the object. Let us take the object point alone. This object point is at a distance of 10 centimeter and three images are formed. One image is the image formed by the lens as the rays travel to the right. So when the rays travel towards the right and from the object, they get refracted from the lens, and this refracted rays appear to comes from the point, and this point is treated as the image point I1, and this is going to be the virtual image of this convex lens, because the object is kept between the focus and the pole of the lens. Next, the image formed after the rays reflect from the mirror. You can see that the refracted rays from the lens is going to the convex mirror, so that for the convex mirror the image I1 will act as an object. Now after reflection, these rays are moving in this direction, and this reflected ray is appear to come from this point, and it says that I2 is the image point for the convex mirror. Then next, the final image after leftward traveling rays once again pass through the lens. You can see that this reflected ray again it is going back to the lens. If they are going back to the lens, then this image I2 of the convex mirror will act like an object of the convex lens again. Once it is passes through the lens, it got refracted, and this refracted rays appears to comes from the point I3, and this is the image point after refraction from the lens. So we need to find out what is the location of these three images from the respective optical devices. See children, whenever you try to solve this kind of problem, you must be very careful that you must use a proper sign convention. So what is the proper sign convention here? Whenever you measure any distance, it should be measured from the pole. And if you measure in the direction of incident ray, that should be treated as positive. If you measure opposite to the direction of incident ray, it should be treated as negative, right? Now let us try to calculate, and here the image of one optical device will try to act as object for another optical device. To solve this problem, let us take separately lens and separately a mirror and then separately a lens, and if we apply the mirror formula, lens formula separately, then we can easily determine what is the location of every image point. And you see that there are two refraction from the lens and one reflection from the mirror. So here, to find out the image point, first one refraction is happening from the lens, another one reflection is happening from the convex mirror, and another one refraction is happening from the lens. And we know the respective equations. For lens equation, it is 1 by v minus 1 by u. For convex mirror, that is 1 by v plus 1 by u. For lens, it is 1 by f is equal to 1 by v minus 1 by u. And we need the image distance. So 1 by v is equal to 1 by f plus 1 by u. And 1 by v is equal to, since the convex lens focal length is positive, let me substitute as it is. Since we are taking the object opposite to the direction of incident ray, it should be treated as negative. So minus 1 by 10, then v will be equal to minus 20 centimeter. It says that the image is forming at the same side of the lens, and it is forming at a distance of 20 centimeter. Now we can conclude that the locations are, for I1, the distance is 20 centimeter from the left of lens, right? Then let us come to the convex mirror. Now the image of the convex lens will act as object for convex mirror, so that the object distance is again 20 plus 5, 25 centimeter. Again the incident ray is in this direction and we are taking the measurement opposite to the direction. So the u will be treated as negative here. Then 1 by v is equal to 1 by f minus 1 by u. For convex mirror the focal length will be positive and the f is given as 1 by 15. Since the object distance is 20 plus 5, 25, minus into minus plus, it will be 1 by 25. Then 1 by v is equal to, then this will be 16 by 150. Then v is equal to 75 by 8, and this is coming out to be plus 8 centimeter, 75 by 8 centimeter. If we do further simplification, it will be 9.37 approximately. This is v, and since it is plus, it says that you have to put the value in the direction of incident ray from the convex mirror. Now this distance is taken as 9.37 centimeter. Now this image will act as object for convex lens again. Now let us take 1 by v is equal to 1 by f plus 1 by u. Then 1 by v is equal to 1 by f. What is the focal length of the lens? It is 20 centimeter. Substitute 20. Now you can see that the incident ray is going from right to left, so that if I try to calculate the object distance, it is against the direction of incident ray. And you can see that the distance is 5 centimeter plus 9.37 centimeter. Let me calculate separately. 5 plus this 9.37, I can write it as 75 by 8. Then this will be equal to 115 by 8. Let us substitute here and it should be treated as negative. Minus 115 by 8. Then 1 by v is equal to 115 minus 160, 2300. Then v is equal to 2300 divided by minus 45. Then v will be approximately equal to 51.1 centimeter, and again it is coming as negative value. So the negative sign says that again you have to go opposite to the direction of incident ray, and the distance from the lens, it will be this distance, which is given as 51.1 centimeter. So we can tell that the location of image I2 is at a distance of 9.37 centimeter. It is from the right of mirror. Or you can write to the left of lens or to the right of mirror. That will be even more grammatically correct. And here, if you look at the location of image I3, then this is 51.1 centimeter to the right of lens. So these are the position of the images and their respective distances. It is very easy, right?